Hello everybody, we will be continuing on with circles and we'll be working with inscribed angles and external angles. So to connect this what we did before we had central angles, and we know that if we have the central angle 105 degrees, then we know that the corresponding arc is also going to be 105 degrees. Those are equal. And so if this is a central angle, an inscribed angle is going to look just like this. So no longer does that angle lie on the center, the angle lies on the circumference. But as you can see here, this arc is going to be the same as this arc, right? So this time, this new angle, inscribed angle theorem, if this is 105, this inscribed angle is not going to be 105, it's going to be half of 105, so it's going to be 52.5 degrees. Okay, so that's the whole theorem summed up in a picture, is that the angle is always half of the arc that it intercepts. Okay, so an inscribed angle theorem and its technicality is inscribed angle is half as big as the corresponding arc and that central angle. So that means if we want to make like some sort of equation for that, we can make the inscribed angle, that's the inscribed angle, is equals 1/2 times the arc. Okay, so you can use that. And we are also going to work with an external angle theorem, and the external angle is right here. It's called external because it's on the external side of the circle. And what this one says is the external angle is half as big as the difference of the intercepted arcs. So this one is actually a little easier to visualize with the equation, but this right here is the first intercepted arc. We're going to label that with a capital ARC, and then this one right here, that's going to be a lowercase ARC, right? Big arc, little arc. So this external angle, this time we're going to label it external angle, is half as big as the difference. So it's going to be the big arc minus the little arc. Okay, and we don't necessarily need to go over why these are. You guys are able to, write these down and use these throughout the lesson and throughout the quiz as well. Okay, so you just have to know how to use these pretty simple equations. Okay, so let's go over a couple examples. So we have a circle here, and we want to find x. So notice that the x here is an inscribed angle, and we are given the corresponding arc, 150. This is the arc 150. So this line right here, it's just a chord. Although it just like connects those, it's not really necessary for the problem, right? So what I would do, once you see that inscribed angle, I would trace it, so you know that this is the only bit of information that you're working with. You just have this angle and that arc 150. So if this is half of 150, if you want, you can set up an equation. Inscribed angle is 1/2 of the arc. That means x is 1/2 of 50, so x is 75 degrees, half of that, no problem. Okay, and so we should also be able to do it when we have a little more information here. So here we want to find arc DC, arc DC. So this is what we're trying to find. So if you want to find that arc, then that means we have to find the corresponding inscribed angle. So it looks like if we trace the arc down to the angles, we can either use this inscribed angle right here, or we can use this inscribed angle right here. But we don't have this one, so what's going to give us this info is whatever this angle is, right? So since this is 43 degrees, that's going to be half as big as this. We can just double the 43 to get the arc 86, right? So the inscribed angle is half the arc. The inscribed angle this time is 43, is 1/2 the arc, and then we can just multiply both sides by 2 to get rid of this 1/2. Times 2. We multiply this side times 2 also, so we get 86 degrees is that arc. 86 degrees. Or the alternative way, if you just remember this is half of that, you can just get 43 and multiply it by 2, which is 86 degrees. Both of these work. Okay, and you should be able to apply these to problems where we have variables. Okay, so we have an inscribed angle, we have the arc. The one relationship that we can use here is that this is half of that. So this is when it becomes a little easier just to use the equation. The inscribed angle is half the arc, so you get the inscribed angle 55, equals 1/2 times 8x plus 14, and then you go ahead and solve. X equals 12. Or another way to do it is, if the inscribed angle is half as big as this, can't we also just multiply whatever this is by 2 to get the big arc? So another version of this that you could do is you can actually do to multiply this inscribed angle to get the big arc, and you should get the same exact thing. And we do x equals 12. So that's our first theorem that we're going to use, but we're also going to use a second theorem, the one about the external angle. And that one is just like this one, where we just set it up, make sure we know what part represents what. Okay, so let's go ahead and find x. So since we have an angle on the outside, we know to use the external angle theorem. You don't have to memorize the theorem, you just have to know how to use it. The external angle is half as big as the big arc minus the small arc, right? So our big arc is 152 right here. The small arc that is intercepted is in between them, 62. So the external angle is x, so x equals 1/2 times 152 minus 62, and that x is 45 degrees. Wow, super enthralling. Can apply the same here. Now we have to find the x, but it's the arc, right? So we have an external angle theorem. That's the only theorem we have for external angles. So the external angle is 1/2 arc minus arc. The external angle is given. That's going to be 59. So we get 59 equals 1/2. The big arc is x minus 62. And then we can solve using opposite operations. I multiplied both sides by 2. We get 118 equals x minus 62, and we get 180. So this x up here is 180 degrees. And then, once again, we can apply this to a problem with x. All right, so just remember how to use it. Like I said, you don't have to memorize these things. It's important to know how to use them. Memorizing is less important. The external angle is 1/2 times the arc minus arc. It's just all about the setup. Once you set it up, it's basically integrated one work. But here, the one thing is that you need to be careful for is when you have the external angle equals 1/2 times the big arc minus the small arc. This small arc, we need to put in parentheses, right? Because this subtracting that arc, it needs to apply to both. Okay, so this is really important that that's in parentheses. Then we have an invisible 1, distribute that, and then we combine like terms. This time I distributed the 1/2. You get 2x plus 6. Solve a little more and we get x equals 12. Thank you for listening.